Hi everybody, Patrick here from EngineeringShock.com, ElectronicLessons.com, and PaintballProps.com. This is our 8th project for our multi-project electronics learning board. This is drive a motor with IR. IR is infrared. We're going to use a TV remote control to drive a little phone vibrator motor. It's actually a very simple circuit. Don't let this confuse you. If you haven't read, or sorry, rather watched the tutorials listed below, the learning board has 11 tutorials, and those are related to each block within the learning board. So if you watch those tutorials, you'll really understand what's going on in this block diagram / schematic. Anyhow, we've got our IR sensor. Now the IR sensor is driven when you aim a remote control, or sorry, an infrared TV remote control at it. But the output is normally 5 volts. So it sits at 5 volts until you aim a controller at it, at which point it starts driving the output low and high and low and high, giving you different pulse widths of square wave signals. That works with encoders within your TV to change channels. Different buttons give you different lengths of square waves. Anyway, that aside, all we want to do is use this to drive a relay. Drive a motor. We could use it to drive a relay, but that'll be another. We'll talk about that another time. So it's normally sitting at 5 volts. Let's pretend that we don't have a remote control. It's just sitting at 5 volts. If we put that 5 volts directly on the input of a trigger of our 555 timer in monostable mode, then the output of the 555 timer in monostable mode will always be high too. There will be no pulse widthening. It will always be high. So what we need to do is we need to bring the output of the infrared sensor low. How do we do that? We're going to use one of our comparators to basically make what's called an inverter. An inverter is a digital gate that reverses logic. So if we had an inverter at the output of the IR sensor, then the output would be normally low, and when we drove it, it would go high. Anyhow, so we'll go through this on the learning board in just a second. So what I'm going to do is I'm going to take the output of the infrared sensor, and I'm going to put it on the negative input of my comparator. So CMP1, comparator 1, negative. And I'm going to put 2.5 volts from a variable resistor on the positive. Now the 2.5 volts on our variable resistor, the VAR1 pin, can be tuned by taking your multimeter, black probe on the negative, or anywhere on the ground line within the system, positive on the VAR1 pin. Use the variable resistor to tune it to 5 volts. We will do that in just a minute. So if we have 2.5 volts on our positive, and the output of the IR sensor is always high, that means it's VCC, so there's 5 volts. There should be 5 volts here, and 2.5 volts here. Now what do we know about comparators? If there's more voltage on the negative than there's the positive, the output is low. If there's more voltage at the positive than the negative, then the output is high. So, by default, we've basically just changed the logic here from normally high to normally low. We've inverted it. Now what happens when we drive it? When we do that, when we aim our remote control at it and we start getting these pulses. As soon as the voltage goes low here, past 2.5 volts, then there is more voltage at the positive input than the negative input. We'll have less than 2.5 volts here. Sorry. Negative 2.5 volts there. And so when there will be more voltage at the positive than the negative, the output will go high. And that's what we want to do to drive our monostable multivibrator. So as soon as that pulse goes low at the input, the output of the comparator goes high, and that triggers our monostable multivibrator. Now I know that might be a little bit confusing. Again, if you watch the tutorials below, this will make more sense to you. So as soon as this pulse goes high at the output of the comparator, triggers the monostable multivibrator. We can tune the output of the multivibrator to go for a little pulse width. For a long pulse width, we can adjust it using the DLY potentiometer. And again, you'll see this in just a minute. You'll see how this makes sense. You'll see it in a lab situation. So once we've tuned that, we're basically going to tune that for 1 second. We're going to tune that for a 1 second pulse width. And And then once we do that, we're going to connect that to the actuator pin. Now actually I missed a step here. In order to determine how long our pulse width is, how do we know? We're going to have to connect that to our LED. Now as soon as we connect that to our LED, as long as the output goes high, 5 volts, the LED will turn on. We've got a 390 ohm protective resistor here, our 3mm red LED. It will light up as when the output of the 555 timer is high, 5 volts. So that's our LED indicator. Once we've tuned it to a 1 second duration, we connect the DLY output to the ACT input actuator, and we're going to set the circuit up so that it drives a mini vibrator motor. This is the driver circuit by default: 1K ohm protective resistor, 2N2222 NPN transistor, our base, our collector, our emitter. When the output is high, it drives the base of the transistor, and one of these 2 pins, there's 2 pins on the board to actually connect the motor. 5 volts in drive, 5 volts is connected to VCC, so we'll place one of our leads of our motor to that pin, and our second to our drive pin. The drive pin, of course, will act to sync current through the entire circuit to ground, completing the circuit, enabling the motor when the output goes from low to high. This needs to be energized in order for this to happen. So, why don't we have a look at this on the board and actually do the step-by-step so that you understand what's going on. I realize that this is a bit messy and that it might be a little bit difficult to understand. So first things first, this is our IR sensor right here. The output of the IR sensor is right here labeled IR. Now, the IR sensor is pointing away from you, but if you have a TV remote control and you aim it across the room, the sensor likely will pick it up. Now, just to understand the output, how it really works, watch the tutorial listed below. But okay, so what I'm going to do here is, first of all, I'm going to show you why we can't plug the IR sensor directly into the input of our monostable multivibrator. I'm going to connect the IR output to the monostable input directly, and I'm going to take the output of the 555 timer in monostable mode, connect to our LED. That LED will always stay on because the output of the infrared sensor is always high. So I'm going to take that off right now. And what we're going to do is, first things first, we're going to tune the variable resistor. Now I need to grab my multimeter, but what you need to do is, this is the VAR1 output right here. This is the VAR1 potentiometer. So basically you take your multimeter, connect it to the ground line, which is right here, or any of these ground pins on the bottom here, and then connect the positive probe to the VAR1 line, and use this potentiometer, use a screwdriver to tune the output to, say, 2.5 volts. After you've done that, the next step is to set up our inverter. So I've tuned it. I've got my positive lead on the VAR1 pin, my negative on the top of the 7805 volt regulator. My output voltage is 2.532 volts, close enough. So, what are we going to do then? We are going to take that 2.5 volts on the VAR1 output, and we're going to place that on the positive input of our comparator, which is labeled CMP1+. We're going to take the infrared output and connect that to our CMP1 negative, as seen in the block diagram schematic. Before I get to the comparator output, I want to calibrate my 555 timer output. So I'm going to take the DLY output and I'm going to connect it to my LED. Now I can manually trigger the 555 timer by using the DLY button. So I've got a relatively long pulse width there. If I want to shorten the pulse width, I'll take my screwdriver on the DLY potentiometer, and I will turn it right. Watch the LED. Shorter. If I keep turning it right, much shorter. So I can keep going to make it so it's almost non-existent. But I'm going to turn it left for about, so it changes for about 1 second. 1 Mississippi, 2 Mississippi, 3 okay, I'll turn it down to 2 seconds. About 1 Mississippi, 2 Mississippi. Good enough. 2 seconds. So basically, that means that once we've connected our monostable out, this line right here, to our actuator pin, and we connect our motor right here, as long as that LED is high, the motor should be running. But I'm going to be disconnecting that from the LED, so our indicator will be that the motor is actually running. So, what's next? Now we need to connect our comparator output to our in line on the monostable multivibrator. So I'm going to remove this. I'm going to connect the in pin, which is the input trigger to the 555 timer, and I'm going to connect that to our CMP1 out, comparator 1 output. So now we've got our inverted signal as we talked about, and I'm going to now, my plan is to take the output of the 555 timer, the DLY output, right here, and I'm going to connect that to the actuator pin, ACT. But before I do that, what I want to do is I want to make sure that our actuator is set up. The actuator pin, there's actuator pins here. There's a 6-pin rail. The left pins are labeled buzz for buzzer, the middle pins are RLY for relay, and the rightmost pins are MTR for motor. So what I need to do is I need to remove the 2-pin header, and I need to place it on the rightmost pins, labeled MTR. Hopefully that's pretty simple. I know that this is a little bit blurry. So now I need to go get my motor and plug it in. What I've done is I've connected my little motor to the motor driver pins, terminal block rather. Red wire to 5-volt line left, and blue wire to the DRV pin right. And I've connected the calibrated output of the 555 timer to the actuator input. So once I plug it in, this little guy is going to jump all around. Now when I sell the board, as I said, it's only pre-order right now, there will be longer extensions on the wire, so that won't be an issue. When I plug it in, I will likely get a false trigger, and then I'm going to try to hold it down because I don't want it jumping around. I'm going to use my right hand to use the infrared trigger to turn it on. So, pardon me, I wish I had 3 hands here. Okay, there's a false trigger. There you go. Now you don't want to do it too many times because the motor gets kind of hot because it's being driven, and these vibration motors aren't meant to be driven for longer than a few seconds at a time. Hence, when you have your BlackBerry or your app, your iPhone or your Galaxy S4, your motor only vibrates for a certain amount of time. Anyhow, that's this video. It was a bit more complicated than some of the other ones, but we've got some more fun and interesting projects coming up. We're at the halfway point almost. This board will be available for sale at the end of August. Check us out at engineeringshock.com and electroniclessons.com. Thanks, guys.